Good morning to everyone. Today, the first class of third graders of the last week of March. So I'm correcting on page 111, exercises 32 and 34. Okay, so let's see. 32, butane C4H10 is a common domestic fuel sold in 12.5 kilogram cylinders. So this, the mass. When it's burned, it produces carbon dioxide and water. How much carbon dioxide by mass uh, would be given off if 100 cylinders of butane were burned? This is per cylinder, and they ask for about 100 cylinders. And we need to know, remember when you burn, you need oxygen all the times. Oxygen is O2, it's a diatomic molecule, and it produces carbon dioxide and water vapor. And they are asking for the amount of mass produced when you are working with this number of cylinders, 100 cylinders. So 100 cylinders multiplied by 12.5 kilograms per one cylinder, and it equals, okay, so you have, sorry, you have 1,250 kilograms of butane. And now, work all the time. Balance the chemical equation. You have 4 times, you have 5 times, okay? 4 multiplied by 2. Remember, oxygen is the last step of the balancing process. So you have 8 oxygens plus 5 oxygens, 13. Choose the number, multiply by an even number to produce an odd number. Is a fraction, is 13 halves. Okay, 13 halves. So now, once you have this, copy below each one the atomic masses. Okay, so you have to do the next, and you have the first one. Okay, you have 4 times the mass of the carbon, which is 12. Okay, it's 58. 58 grams. Here you have 13 halves of the mass of oxygen, which is 2 times 16, 32. So is 208 grams. CO2 is 4 times 44 grams, 5 times 18 grams, and it yields 44 multiplied by 4, 176, and 5 times 18, and it yields 90 grams. So the theory says from 58 grams of butane, there are 90 grams of, 176 grams of CO2. The question is the mass produced from 100 cylinders whose mass is 12.5 kilograms. So you have this working grams, cross out both units, grams of CH4. And now you can work the same way as we did yesterday. This is the real amount, X grams of CO2. The theoretical amount is, in this case, you have 58 grams and 176. Then you solve the equation, okay, and you will have 1,250,000 grams, and you will have 58 grams down and 176 grams. You can do the conversion factor directly, okay? So, is 3.79 multiplied by 10 to the power of 6 grams, or what you have there is they say, okay, in kilograms you have there 3,784, more or less. Okay, so this is in kilograms you will have 3.79 multiplied by 10 to the power of 3 kilograms. Okay, this is the way to work with this. Okay, use the following in exercise 34. They say use the following unbalanced chemical equation to decide whether the statements below are true or false. So let's see the answers. I guess you are correct in the exercises. Okay, they say the first one. The first one in which you have the equation is the reaction between nitrogen and hydrogen, and it yields ammonia. Okay, so you have 2 atoms of nitrogen, 2 of ammonia, 6 of hydrogen, 3 times 2, 6 of hydrogen. And now, 1 grain of nitrogen will react with 3 grams of hydrogen. This is the first question. True or false? Okay, we can add the theoretical masses here, the molar masses. Okay, you have here 28 grams, 3 times 2, which is 6 grams, and here you have 2 times 17 grams, is 34 grams. Okay, theory. This is the theory. And now the reality says, okay, now from 1 grain, 3 grams of hydrogen will we need it? You can take with a direct proportion. 1 grain from 6 grams, we will need X grams of hydrogen. And now we have to calculate, but it's obviously that is not right, okay? Because from a higher mass, you need a lower mass. So here is put it in a different way. So you will have 6 divided by 28. Okay, it's 0.21, 0.21. X equals 0.21 grams of hydrogen. What does it mean? You have more, you have 3 grams, okay? You have 3 grams. So this is not the limiting reactant. Limiting reactant is nitrogen. Is nitrogen, okay? So it's false. The second question, 1 mole of nitrogen reacts with 1 mole of hydrogen? No, because 1 mole of nitrogen reacts with 3 moles of hydrogen, so it's false. The third one, 1 mole of nitrogen requires 3 times the quantity in mole of hydrogen. That's it. This is the conclusion, so true. This is the same as this one. D, 28 grams of nitrogen react with 2 grams of hydrogen in order to form 50 grams of ammonia in this mass ratio. False, completely false, because to correct it, you have to say 28 grams of nitrogen reacts with 6 grams of hydrogen and it yields 34 grams of ammonia. Okay, now, in the second video, I'm trying to explain how to balance a chemical equation when it's not obvious to balance directly. Okay, we are working with the mathematical equations method. Let's